Will the industrial internet change manufacturing to the degree the industrial revolution did? In, like, say, 20 years when we look back, how will they be compared?
Yeah, I think that when you think about manufacturing 20 years from now, the computer and the network is going to be much more fundamental. Your factories are going to look a lot more like data centers do, where there's a much greater degree of automation that's driven by the fact that you have good data feeds off of it. You have a lot of your administration of the factory able to be done remotely or in a back office. You don't necessarily need to have engineers on a floor watching a machine in order to know what's going on. And I think fundamentally the kind of number of players in a factory will be much smaller. You'll have much more technical expertise, but fewer number of people overall in a factory setting.
So a lot more automation.
Mm-hmm.
What are the fundamental ways manufacturing is changing starting now?
I would say the biggest one is a focus on quality and efficiency. We see a lot more plants now which run 24/7 and which have a much higher level of efficiency. I would also say that the ability to track product quality is much higher. I mean, if you think about the kind of previous industrial revolution, which was based on the Toyota production system and Kaizen, I mean, that got us to be able to build a car with 30,000 parts and have very, very low defect rates across a fleet. I think that the next industrial revolution, you may be looking at, cars per defect rather than defects per car.
Interesting. And so are manufacturers ready for this?
Absolutely. Most manufacturers do some form of data collection, at least at kind of at a high level. The next industrial revolution is about automating the collection of that data. It's about being able to get insights out of that data that you wouldn't be able to without a computer. And it's about being able to do predictive and prescriptive adjustments to a manufacturing process. In the same way that people don't lay out transistors for chips anymore, I think you're going to start seeing factory floors and factory processes which are designed by computers based on data that's gathered in a factory rather than being planned out manually by engineers.
And you've noted that many of the challenges in adopting these technologies are being mitigated by open standard protocols. How would you describe the standards landscape right now, and where do we need to go?
Well, the standards landscape right now is a little half-baked. Things that are more recent tend to be on open protocols, but there are still a lot of machines that if you want to talk to them, you have to haul out the 500-page Mitsubishi manual or the 500-page Siemens manual and compute which endian order the bits you're talking to are, and construct a driver specifically for that PLC or specifically for that machine. In the future, I think when people, and especially machine builders, realize the advantages of having portable data, that's going to move into more sort of internet-type APIs, things like XML and JSON.
So will they be ecosystem-based, or are we still going to see the sort of top-down build that we're seeing right now?
I mean, I would hope that they're open, but probably at least in the near term, they're going to run along the lines of the technology vendors. So I fully expect equipment makers to kind of start the charge, but I think longer term we'll realize that everything talking the same language is the way to go.
Right. And in recent talks, you've talked about distinctions between machine vision and computer vision. Can you talk a little bit about those distinctions and why machine vision is becoming so important?
Sure. Computer vision in general, I would consider the entire space of processing images and video. So what Google does, recognizing street numbers on houses, is an application of computer vision. Machine vision tends to be specifically inspection for the process of fabrication or assembly. And it tends to be something where you're looking at a very controlled environment, you're looking at a repeatable problem, and you need very, very high levels of accuracy. I would consider machine vision to be within a set of more advanced data signal processing, which is just becoming feasible as kind of part of the factory big data revolution.
So it's a big part of the industrial internet.
Exactly. A lot of your data coming off the plant floor isn't necessarily clean. It's not necessarily organized. Some of it's been structured by machines, but a lot of it also exists in semi-structured or raw data formats, like images, like raw sensor data, and you have to have some level of signal processing in order to structure it into something you can use.
So shifting gears just a little bit here, what kinds of things are you following these days? What people or projects are you interested in?
I'm very interested in the Pi data, Pi science field. I spend a lot of my time in front of an IPython notebook, and I feel like that is a pretty new and pretty interesting paradigm for statistical computing. I'm also very, very much in love with the Arduino culture and the maker culture. So seeing people building machines in their garages is something that I think will definitely continue. I also feel like that there's quite a bit happening with robotics, and I follow a lot of the kind of post-Willow Garage startups. So Willow Garage was where OpenCV kind of was maintained for a number of years. A number of startups, both in robotics and computer vision, have come out of it, and it's going to be really exciting to see more of kind of this Silicon Valley ethos applied to the intersection of computing and the physical world.
That's interesting. Thank you very much for talking with me today.
Thank you, Jen.